Hello, this is Mrs. Dehn-Brastad, and today we're going to talk about Chapter 1, Section 1 of your geometry book, which is called Understanding Points, Lines, and Planes. So we're going to start with this warm-up. This is asking if you could try each of these problems on your own paper, and then we'll check and see if you got the right answers. Now I accidentally hit a button, and you can see that x greater than or equal to 3, you would put a solid dot at the 3 and then an arrow going to the right. So dot and then an arrow this way. The second question said x is greater than, or 2 is less than, or x is greater than 2 or equal to. So, and also x is less than or equal to 6. So you have to think of a number that is between 2 and 6, like 4. They included 4. We put solid dots at 2, solid dots at 6, and then we want to include everything in between there. And then for our last one, x is less than 1 or x is less than 0. Are you surprised about how this looks? Less than 1, you would go this way. X is greater than 0, you would go this way. Notice that they overlap each other, which is why the answer is just this whole thing. Our objectives for this lesson are to identify, name, and draw points, lines, segments, rays, and planes, and also to apply basic facts about points, lines, and planes. We have many actually, vocabulary words for this section. There is a notebook, a note-taking guide that you will fill in your vocabulary words, and these are the ones that are in this section. There's a lot of vocab words for Chapter 1. Here's our first vocabulary word, undefined terms. They are the most basic figures in geometry. They cannot be defined by using other figures. The undefined terms that we're going to work with are point, line, and plane, and they are considered to be the building blocks of geometry. Even though we can't define them, we can describe them, which is good for us. So here we go with our first one, a point. A point names a location. It has no size. We use a dot because we have to put something there, so we just put a dot. And you use a capital letter to name it. A line is a straight path that has no thickness and extends forever, but we represent it by drawing a line, which of course then has at least our thickness of our pencil. We represent it with 2 uppercase letters that are on the line. These points are on the line, or you can even use a lowercase letter that is the name of that line. Notice that there is arrows that show that this line goes on forever. That's very important. A plane is a flat surface that has no thickness and extends forever. We usually draw it by making kind of a lopsided rectangle, like a rhombus shape or a parallelogram. This kind of says to us that it's a 2-dimensional object. And you can make kind of a fancy capital letter to name the plane. We usually will name it by 3 points on the plane. Any 3 points are lying on the plane. Another vocabulary word is collinear. If you have points that lie on the same line, we say that they are collinear. In this example, the points K, L, and M are collinear because they lie on the same line. Points that lie on the same plane are coplanar. They could also be non-coplanar, or you could have non-collinear. If we say that this is one 2-dimensional surface, like on a piece of paper, then these would all be coplanar points. This is just an example to see if you're following along with what we've got so far. Name 4 coplanar points. If we look at this figure here, this kind of diamond shape, this is saying that these are on the same plane. So the corners of that is called A, B, C, D. So those points are coplanar. I'm not sure if there's any other ones that are on here. Let me erase this and see if we see anything else. I wouldn't be able to name any other coplanar points than those because those are on that one plane that they're showing. 3 lines, though, there's lots of lines. I think this must be E right here. So EC would be a line. And when you name a line, you use capital letters, and then you draw a little line with arrows on both ends over top of it. Let's see. We have a line from A to E. We have B to E. We have D to E. So those are all examples of lines. BC looks to me like a segment, not a line. It doesn't look like that line would extend forever. But you could draw, you know, if we added on a little bit of extra, then you could say it's a line. And here's our possible solutions. AE, we got that one. BE, we talked about that one, but I didn't write it. Oh, here's another thing. The line EC is the same as the line CE. You can switch the order of the points on the line. If it's a line with arrows at both ends, it doesn't matter which order you write your points. This one says use the diagram to name two planes. We have to have at least 3 points to name a plane. So even though this up here doesn't look like the way I've showed you to draw planes, it is a plane. 3 points is enough for a plane. So we have one plane is ABC, and another plane is this quadrilateral figure down. You only need 3 of these points to name the plane, or you can name it capital R. Okay, here's some more terms. Now these we actually can define. A segment is a line segment is the part of the line consisting of 2 points and all the points between them. We name it by its endpoints. It can be either way, AB or BA. We draw it with 2 endpoints, no arrows. An endpoint is a point at the end of a segment or the starting point of a ray. It gets named also with a capital letter, of course, because it is a point. So we have an endpoint here, C. We have another endpoint, D. A ray is a part of a line that starts at an endpoint and extends forever in one direction. You have to name a ray with its endpoint listed first, and then you draw this little arrow thing above it. Just the arrow only points one way. A little ray. Opposite rays are 2 rays that have a common endpoint and form a line. So these 2 rays would be EF going this way and EG going this way. Common endpoint there is E. And you notice that both of those rays over here are named with the E listed first. That's very important. So common rays form a straight line. It says draw and label each of the following: a segment with endpoints M and N. And then opposite rays with a common endpoint T. So think about how you would do that before I hit the button so you could check. So there's an example of a segment with endpoints M and N. And here's an example of opposite rays with a common endpoint T. Draw and label a ray with endpoint M that contains N. So we know we have to have one endpoint M. Now it doesn't matter which way you draw your ray. You can go any way you want. You could go this way, or you could go this way or this way. But you have to have another point on your ray, and that would be N. Now to label it, we always put the endpoint first, and then we put a little ray over top of it. So the book examples has M as the endpoint. They're going straight to the right there, and then there's their other point N. A postulate, we will use the term postulate a lot in geometry. A postulate, also called an axiom, is a statement that is accepted as true without proof. Postulates about points, lines, and planes help describe geometric properties. So properties, we don't have to, postulates do not have to be proven. All right, here we have 3 postulates. In your note-taking guide for Chapter 1, the postulates are already written down. You want to be able to refer back to them, so find them in your note-taking guide and make sure that you can see where they're at and maybe star them or something. So the first postulate is, through any 2 points, there is exactly one line. Postulates usually will make a lot of sense. Well, if you have any 2 points, let me make them different. There's really only one line that could go through those 2 points, right? That is not a very good line, but through any 2 points, there's exactly, I can't draw a straight line. My freehand lines are terrible. but there's only one line that would go through any 2 points. Through any 3 non-collinear points, there's exactly one plane containing them. If 2 points lie in a plane, then the line containing those points lies in the plane. Let me say that one again. 2 points, so you have 2 points, and they're lying in a plane. I'm going to draw kind of a piece of paper here for my plane. Here's my 2 points. And it says a line containing those 2 points has to lie, whoops, in a plane. Sorry, how do I go back? There it is. Okay, so if I can try to draw a straight line here. Let's pretend my point was over there then. Hard to draw straight lines freehand on a computer. So there's my straight line, and it went through those 2 points that were on the plane, and that line necessarily then lies in the plane. Name a line that passes through 2 points. Well, that one's pretty easy. It's line XY. Name a plane that contains 3 non-collinear points. Okay, non-collinear means they're not in a line. You can use the 2 that are on the line, G and H, and then the other one has to be F. R is not a point. That fancy looking R is naming the plane. This N is not a point. Points are always named with uppercase letters, capital letters. So you can only name this G, H, F. You can't use the N, you can't use that R. Okay, this is a little review from algebra. Recall that a system of equations is a set of 2 or more equations containing 2 or more of the same variables. The coordinates of the solution of the system satisfy all equations in the system. The coordinates also locate the point where they intersect. An intersection is a set of all points that 2 or more figures have in common. So the next 2 postulates are going to describe intersections with lines and planes. So here's 114 is if 2 lines intersect, they intersect in exactly 1 point. Makes sense? They intersect at exactly 1 point. If 2 planes intersect, then they intersect in exactly 1 line. If you think about a piece of paper going through your desk, it would intersect at a straight line. It says here that you can use a dashed line to show the part of the figure that is kind of invisible. Sketch 2 lines intersecting exactly 1 point. That's easy to do. Sketch a figure that shows a line that lies in a plane. That's all you have to do. Sketch a figure that shows 2 lines intersect in 1 point in a plane, but only one of the lines lies in the plane. So that one's a little bit trickier. 2 lines intersect in 1 point in a plane. So the point is in the plane, but the 2 lines are not. 1 line is in the plane, 1 line is not. So 1 line must be like poking through the paper. So you can see here that the line that the horizontal line is the one on the plane, and this kind of diagonal line is poking through that plane, and they're meeting right here at this point. The dash part is just showing that that part of the line is really underneath that plane, underneath that like paper, and you couldn't really see it, but we'd sketched it dashed so that you can see what it looked like. Okay, now just to wrap up this section, this is just a really short little quiz. You're not graded on it, but take a minute, pause the video here, and see if you can use this figure, this sketch, to answer these questions. So pause the video and answer these questions. Here's the answers. I hope you actually tried these. So the answer for number 1, 2 opposite rays are CB and CD. A point on BC, ray BC. A possible answer is D. So ray BC might be like, that's a line, BC. But it can be a ray because you can say, well, from right here this way is a ray. And D is on that. The intersection of plane N and plane T. Plane N is the purpley blue color. Plane T is that reddish color. They intersect at a line. And that line's name is either BC or BD. BC is also correct. You could also flip-flop the order of the endpoints, so it could be DB or CB. A plane containing points E, D, and B. E, D, and B. That's the red plane. Now you can either name the plane with that fancy letter T, or you could have named it as plane EDB. Or is there any other points? Or you could have put C on that too. It could be ECB or BCE if you wanted to go in alphabetical order. You can't use A though, and you can't use the N. Okay, for this part you're going to do a little sketching. So again, pause the video, answer these two questions, and then we'll check your answers. So the answers are, if you are going to draw a line intersecting a plane at one point, draw your plane and then show a line poking through it. The dash part means that would be under the plane. And then to draw a ray with the endpoint P that passes through Q, that's all you have to do. Make sure P is the endpoint. Okay, thank you very much.